Hi everyone, my name is Thomas Kim. Today is June 17th, 2021. This is my 7th episode about Qt6 and 3D graphics with Vulkan. In this episode, I will discuss must-know C++20 concept constrained auto, advanced RAII, Vulkan in action. This is ISO CPP official C++ homepage. Current ISO C++ status. C++20 standard is published. C++23 on the way. If you scroll down, you can find reflection. As of today, reflection is not yet implemented, but I believe this reflection will be implemented in near future. If this reflection is implemented, then my C++ library extension will be significantly simplified. I mean, I'm looking forward to C++20 reflection. In this episode, I will discuss concept constrained auto. Please refer to this documentation. As of today, this syntax is not yet supported. Also, please refer to this documentation. Yet another approach for constraint declaration. If you scroll down, you can find this syntax. Here, sortable is concept. I will introduce this syntax in this episode. Without further ado, let's get started. Start Visual Studio 2019. Go to File, New, Project, Vulkan App. Click Next. Project name, I will just say Vulkan App. Solution name 007 Vulkan App. Click Create. Now select Configuration Manager. Click this button. Edit. Make sure x86 is selected. Remove. Yes. Close. Close. We created this template in our previous episode. I will arrange side by side and I will unpin. Press F5 for debug build. You should see Vulkan template. Your program should build and run successfully. Now close it. If you missed my previous episode 06, you may not able to create this project. Control click. In episode 6, we created a Visual Studio project template for Vulkan programming. If you haven't watched my previous video, you cannot create Vulkan application with a mouse click. Also, if you click Vulkan tutorial, you can read base code. I will implement this part for Vulkan programming. I will make it small here. Class hello triangle application. I will make it template auto width 800 auto height 600. I will delete this part. Try, catch, constant std, exception, e, stream, error, e, what, return, exit, failure, exit failure, exit success. These are defined. Go to definition in the file stdliv.h. I will close it. Now we create an instance. Vulkan is an instance of Hello Triangle application. Now private GLFW window public void run. I will call Vulkan run. Here void init window GLFW init initialize GLFW3 library void cleanup. Because we initialized, we have to terminate GLFW terminate. We are creating a constructor here. In the constructor, we call init window. Copy this. This is destructor. In the destructor, we call cleanup. Now Control F5. Okay, it works successfully. Now close it. In the init window, GLFW window hint GLFW client API GLFW no API. I will make it smaller. GLFW client API is variable tag. GLFW no API is variables value or state of GLFW library. GLFW no API instructs not to create OpenGL context. GLFW Windows hint GLFW resizable. Its value GLFW pulse. Again, GLFW resizable is variable tag. Its value is set to GLFW pulse, which means do not handle Windows resize event. Now we create window. This window, this member is defined here. GLFW create window. The first argument is width. We get this width here. The next is height. We provide this height here. Title Vulkan app. GLW monitor. I will provide null PTR. We use default monitor. GLFW window share null PTR. We do not use window sharing in Vulkan. It's for OpenGL. So we created Windows successfully. Now we have to clean up. If this window GLFW destroy window, this window. Now this window null PTR. Because this cleanup is executed in the destructor. Now scroll up. We haven't initialized window here. In C++, non-class member in class is not initialized by default, but C++ 17 allows initialization. Since C++ 17, we can use initialization in class member for members of a class using this syntax. Press Ctrl F5. Okay, it works correctly. Now, here, void main loop while GLFW window should close. We pass window, then we negate GLFW for events. Now scroll down. In function run main loop, press Ctrl F5. This is our Vulkan window. Now close it. Now we will learn how to use constrained auto and advanced RAII. Start File Explorer, Qt Vulkan, Vulkan app, copy, paste, rename, adv, source.cpp. In Visual Studio, right-click, add existing item, advanced source, add, right-click, properties, exclude from build. Yes. Click Apply. Click OK. This source file is excluded. Now double click it. I will arrange side by side. Now press F5. It should build and run successfully. Now select Release. Press F5. It failed. No, because I made a mistake. Now this is release build. Right-click, Properties, select Release, exclude from build. Yes. Click Apply, click OK. Now this is disabled. Press F5. Now it works successfully. Back to Debug. Save all. We declared an instance of window. This is a pointer. And we cleaned up explicitly. Of course, we can do like this, but there is a better way. Here, I will create a namespace, GLFW. End of namespace GLFW. Template, type name, type, concept, int, type, C, talk, play, fun, types, is, type, in list B, type. We allow int, unsigned, long unsigned long. We defined a concept. We allow type 1 among int unsigned long unsigned long. We allow type to be 1 among this list of types, like this. Type should be one of these types. Now, auto create window. We use concept auto with int type C. This is concept. This concept is defined here. We use the keyword auto, so auto height. Constant character pointer title. We initialize Vulkan app. This is function. Now here auto cleanup auto window. Please note that we use GLFW destroy window. We pass window. This is lambda closer. SDD unique PTR. We pass scroll up GLFW window. Then this type 댓글 type cleanup. This is unique PTR. We create an instance of PTR window. We call create window, copy this, copy, paste, width, this width, height, this height, title, this title. I will typecast int, also int. It should be comma. Then we provide cleanup. We defined an instance WPTR window. Now in this function we return PTR window. For more information about when RAII fails, unique PTR is our rescue. For more information, please watch this video. Control click. In this video, I explained how to use unique PTR for RAII idiom. Now, we need to define a member here. So, using window type, we call this function. We simply pass 00 dummy string, then decl type. We use this function to create Windows type by passing dummy arguments. With this, I will delete GLFW. Please note that we defined this type in namespace GLFW. Window type window. Now this window is unique PTR. Here we don't need this. This window, we are calling this function create window. This function is defined in the namespace GLFW. GLFW create window, we pass width, then height, then title. I will use default value Vulkan app. So this is good enough. Also note that this window is of type SED unique PTR. So we don't need this. Now everything is ready, but this does not work. This window is not GW window. We have to use get. Now press F5. It works perfectly. Using this method, by wrapping pointer in unique PTR, we don't need to concern about resource leak. When this member is destroyed, in the destructor, the destructor of unique PTR is called or invoked prior this destructor. So our application is robust, no resource leak. is possible.